Hello, hello. Yeah. So I hope you are able to hear me, right? Can someone just react with them so that I can start? Okay. So today we will be discussing about. Let me check the stream. Okay. So today we will be discussing about multi-core match tree. So multi-core match tree. So how to leverage two cores. Usually many people see they just only tell the theoretical part that ESP32 is having dual cores, but it is very essential to understand how to use two different cores, right? So how to switch between cores, how can we assign one task to one core and another task to another core. Both will be running at a time simultaneously without any delay. So let's say you are having one for loop, okay, infinite loop. That means it is never ending. So it is infinite for loop. So if you are having infinite for loop in one core, still whatever the things that you have, what tasks that you want that you assigned in the core to, that will definitely that will be running without any blocking. Okay, so which will has asynchronous action. Okay, so yeah, so the agenda is uh, understanding the dual core processors. Okay, and first in order to use this dual core processor we need to take help of one library, that is free RTOS library. Okay, we need to take help of free RTOS library. So in the previous sessions also we might have came across this particular word, free RTOS. So this API, this particular library is essential if you want to assign, if you want to schedule tasks, if you want to if you want to leverage dual cores. Okay, for that you need to take the help of free RTOS library. So the multi-core advantage. So what is the advantage of learning using two cores at a time? Okay, dual cores. So what is the advantage of learning this particular thing? The first one is traditional microcontrollers run code sequentially. If your code waits for a sensor, your display update is blocked, isn't it? So if you want to display some temperature data on your 16 into 2 display module, so first you need to get some data from the sensor and you need to display. And so both the things cannot be happening at a time, isn't it? So usually the code execution of traditional microcontroller, including Arduino Uno 80 mega 328p, which executes the code sequentially. So all traditional microcontrollers execute code sequentially, so not simultaneously. Okay, but if you learn this, if you can take the advantage of multi-core processing, then you can make the code to run simultaneously, not sequentially. So this we call it as parallelism. So parallelism is the property in which code runs at the exact same moment on two separate silicon cores. So both things will be happening at a time. Okay, and determinism. So determinism means, like, let's say some critical things are there. Okay, some critical functions, so which should not be affected by other background processing. No matter whatever the background processes are going on, there are certain critical things which should be executed. Let's say you're working on some healthcare device in which you will be transmitting a heartbeat to let's say some automated heartbeat detection module. You design something, so this heartbeat should be transmitted timely. Let's say some doctor is monitoring your heartbeat. Let's say if due to some background processes, if heartbeat suddenly stopped the transmission, the data is certain tasks are delayed, then it is really ambiguous, right? So that's why we require something which can make the code to run at a time simultaneously, not sequentially. So for sequential execution, there are many microcontrollers, including Arduino Uno 80 mega 328p. But for parallelism, you need to take help of other modules like ESPs. Okay. So responsiveness. See, responsiveness is very important. whenever you're working on any robotic module or whatever, maybe whatever project, whatever IoT project you are trying to build, uh, you might have came across these kind of problems so many times, isn't it? If you move sensor, let's say if you try to move some sensor, then display works. Again, if you just try to move the wires of the display module, then sensor starts working. So this is the default issue that everyone usually faces, isn't it, when you are working on IoT projects? So responsiveness is the important thing. Instant UI feedback while handling complex wireless stacks. So on one side, sensor should detect the values, and at the same time, whatever the values that sensor is detecting, it should be immediately shown in the display module. For that is the, both things should happen simultaneously. But whereas in sequential execution, the LCD module needs to wait until some value is obtained from the sensor. Okay, so if these kind of things causes irresponsiveness. Okay, so total we are having two CPUs inside ESP32. We are having two identical cores. Okay, first one is core 0 and another one is core 1. So this core 0 handles the Wi-Fi stack. See, actually, all these functionalities, RF functionality related to the radio frequency, it could be related to the Wi-Fi, Bluetooth, or any other things. All these are controlled by core 0. Okay, core 0 is responsible to handle Wi-Fi related functionality, Bluetooth, and internal some internal radio housekeeping. So basically all Wi-Fi, Bluetooth, all related radio frequency, RF related parameters are taken care by this particular core 0. And core 1 is responsible for execution of the code. Okay, because see, these the manufacturers of expressive companies, see how brilliant they are. So they know that if Wi-Fi, Bluetooth, if they, they put all this functionality in the same core where the our program that we are writing inside the setup function or loop function. So if we mix both the things, uh, you know they won't be executing at a time. Okay, simultaneously, it will result in a sequential execution. See, Wi-Fi itself takes, RF radio frequency itself takes a little bit of time for establishing a network connection, or else finding a network, scanning a network, isn't it? To find an SSID, nearby SSID network scan, establish a connect network with them. They themselves are a little bit take time taking. They are having some delay, isn't it? So that's why they kept all these things on one core, one CPU, and the other rest of the program in the another core. Okay, so these Wi-Fi and Bluetooth, these are radio frequency related. They themselves are having latency, so they don't execute immediately, right? So they are having some latency. So that's why they just isolated these radio frequency related functionality. They kept all these functionalities in one core and the rest of the program in the another core. So, but both these cores are identical in nature. Okay, both cores are identical in nature. It could be in terms of memory, or it could be whatever else. Both are identical. So when you start using two cores, then the efficiency increases. That is the important point in that slide. So now to use this particular thing, okay, dual core processing, multi core tasking, then we need to take help of this free RTOS library. Yeah. So this is the main function which assigns any task. But before that, we need to import one library. What is that library? Free RTOS library. See, just like we attended the previous session where we discussed about non-volatile storage. In again non-volatile storage, we discussed that there is something like partition, right? We have NVS itself is one partition, and again in partition we are having many namespaces. Like we have taken help of storage namespace, and in that we have stored some value, and then we try to retrieve the value, right? So similarly, for that we have imported two libraries. nvs underscore flash.h and nvs.h. Similarly, to take to use to leverage this particular functionality of using multi-core tasking or to assign any specific task to a particular core, then you need to take the help of free rtvos library. Okay, after importing the free rtvos library, this function is actually this is defined inside the free rtvos library, free rtvos.h. Inside that particular library this function is defined. So yeah, so actually it accepts around 3 4 5 6 7 parameters. It is accepting around 7 parameters. Okay, we need to discuss about